Dear student, today we shall discuss how to derive Planck's radiation formula. That is, the topic is derivation of Planck's radiation formula. So from Planck quantum hypothesis we know black body consists of simple harmonic oscillators and each have characteristic frequency of oscillation. Let's consider a black body radiator has n number of oscillators. That is, let black body radiator has n number of oscillators having fundamental frequency of vibration is nu. So n black body radiator has n number of oscillators having fundamental frequency of vibration is nu. Let n naught number of oscillators, n1 number of oscillators, n2 number of oscillators, ni number of oscillators having their energies having their energy E naught, V1, E2, EI respectively. Now, number of oscillators, say Ni. Number of oscillators having energy just above the E naught. I repeat, number of oscillators having energy above the lowest value E naught is given by Boltzmann distribution law, which is given by that n equal to n naught e to the power minus ei by kt. So this is the Boltzmann distribution law. Boltzmann distribution law. Boltzmann distribution law. So number of oscillators having energy above the E naught is given by this equation. Now applying this equation to the N1, N2, Ni, we get, so N1 equal to, we can write N naught e to the power minus E1 by kt equal to N naught e to the power minus E equal to h nu. So this is 1 h nu. We simply write down h nu kt. Similarly, N2 equal to N naught e to the power minus E2 by kt equal to N naught e to the minus twice h nu by kt. Similarly, Ni equal to N naught e to the power minus Ei by kt equal to N naught e to the power minus IH nu by kt. Now, total number of oscillators number of oscillators capital N in all the energy state, in all the energy state, in all the energy state is given by n equal to n1, say n0 plus n1 plus n2 plus ni. So this is n0 plus, so we can write, say, n0 e to the power minus e0 kt plus n0 e to the power minus h nu by kt plus n0 e to the power minus twice h nu by kt plus n0 e to the minus h nu by kt. Now n0, we can take its summation I equal to 0 to infinity e to the power minus I h nu by kt. So when I equal to 0, e to the power 0, so simply come this n naught. When I equal to 1, so this value comes. When I equal to 2, this value comes. So this is the total number of oscillators in all the energy state. Next, we have to calculate total energy for all the oscillators. Total energy of all the oscillators. Next is the total energy E for all the oscillators. Is given by say E equal to n naught E naught plus n1 E1 plus n2 E2 plus ni ei. Now n naught into 0 plus, what is the value of n1? Value of n1 is n naught e to the power minus h nu by kt, the n1 value. Now what is the e1? E1 will be h nu plus n2 n naught e to the power minus twice h nu by kt. What is the value of e2? It is twice h nu plus the ni, this n naught e to the power minus h nu by kt ei equal to our I h nu. Now take common n naught h nu common. N naught h nu common, we will get n naught h nu common. So it is e to the power minus h nu by kt plus e to the power minus twice h nu by kt 2 into 2 plus and not common h nu common e to the power minus I h nu by kt into I. So in summation form we can write n naught h nu summation I equal to 0 to infinity. We can write I into e to the power minus I h nu by kt. So this is the total energy expression. This is the total number of oscillators. Now if you divide the total energy of the oscillators divided by number of oscillators, we will get the average energy of the oscillators. So the average energy E bar of an oscillator is given by, or can be written as, is given by E bar equal to total energy divided by total number of oscillators. So what is the total energy here? We got just now n naught h nu summation I equal to 0 to infinity I into e to the power minus I h nu by kt divided by n naught summation I equal to 0 to infinity e to the power minus I h nu by kt. Now we shall solve this equation by applying mathematics. Let e to the power minus h nu by kt equal to x. Therefore this equation becomes e bar equal to n naught cancel h nu summation I equal to 0 to infinity I e to the power minus I, this is e to the power x to the power I, and below summation of e to the power, sorry, not e, x to the power only I. Now from mathematics we know from summation of I equal to 0 to infinity x to the power I, just if you expand this we'll get x to the power 0, x to the power 0, that is 1, x to the 0 into 1 plus x square plus x cube plus dot 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 equal to 1 by 1 minus x for x less than 1. And for this another equation we have I equal to 0 to infinity I into x to the power I equal to, if you put the values of 0 it becomes 0, say 0 plus, no need to write 0, so 1 x to 1, that is x plus 2 x square plus 3 x cube. Now takes x common, 1 plus twice x plus 3x square plus and this value is x into 1 by 1 minus x whole square for saying for x less than 1. That is, we final result is x by 1 minus x square. So we got this value and this value. So we can put this value equal to this value, and this value is this value. We get we get now say this is equation number 1. So from 1 e bar equal to, we can put directly h nu into h nu into x by 1 minus x all square, and below 1 by 1 minus x. So on simplification it becomes h nu x 1x cancel, and below is 1 minus x. Now put the values of x. We know x is this is, so this is h nu e to the power minus h nu by kt, and 1 minus e to the power minus h nu by kt. Now multiplying by e to the power h nu by kt, that is, we get equal to h nu, then h nu by kt minus 1. So now number of oscillators per unit volume, that is number of oscillators per unit volume given dn within frequency range is given by dn equal to dn equal to 8 pi nu square c cube d nu. So this is the number of oscillators per unit volume, and we also know the average energy of an oscillator. Therefore the energy density, that is E nu d nu, is equal to number of oscillators per unit volume into average energy of the oscillator. Now applying this, now we get now therefore we can write E nu d nu equal to number of oscillator per unit volume is given by this 8 pi nu square c cube d nu into average energy of the oscillator, it is h nu by e to the power h nu by kt minus 1, and on simplification we get d nu equal to 8 pi 8 pi h nu cube below c cube into 1 by e to the power h nu by k t minus 1 d nu, which is which is the which is the Planck's radiation formula formula in terms of in terms of frequency. This is the Planck's radiation formula in terms of frequency. Now, in terms of wavelength, that is lambda, we can write we know nu equal to c by lambda. We know nu equal to c by lambda. Now on differentiation, d nu equal to minus c is a constant, so 1 by it is c by lambda square d lambda. Now if you take the modulus, simply the d nu will get the values of positive one. We need the modulus one, that is c by lambda square d lambda. Now in terms of wavelength, we can write d lambda equal to 8 pi h. Now this nu is c by lambda to the cube. This is c cube into 1 by e to the power h. Nu is c by lambda. We can write directly c to lambda kt minus 1 into d nu is c by lambda square d lambda. So it ultimately the equation becomes c cube cancel, 8 pi h c. In the below lambda cube, lambda square, lambda to the power 5, 1 by e to the power hc by lambda kt minus 1 d lambda, which is Planck's radiation formula in terms of wavelength. So we have derived Planck's radiation formula in terms of frequency. This is the Planck's radiation formula in terms of wavelength. So thank you very much for watching this video. Dear student, there is a minor correction in the mathematics. That is, it is corrected as summation of I equal to 0 to infinity x to the power I equal to, when I equal to 0, so x to the power 0 equal to 1 plus x square plus x cube equal to 1 by 1 minus x for x less than 1. So this is the correction term in the formulation of Planck's radiation formula. So thank you for watching this video.